Assalamualaikum and a very good day. So class, now we still under chapter 4, which is matrices. We have completed week 11 part 1, which is matrix transpose. So now we go to week 11 part 2. We will cover here determinant of matrices, which consists of determinant of 2 by 2 and also determinant of 3 by 3 matrix. If the matrix A is a square matrix, then we can compute the determinant of matrix A, which is here is written by this notation. And this is not absolute value when it comes to the matrix. When it comes to the matrix, this notation means that it is determinant of the matrix. Now we go to the properties of the theorem of the determinant. For a square matrix A, if let's say you have here, you compute here the determinant of A matrix, it will be equal with the determinant of A transpose. For a square matrices A and B of the same order means that, for example, A is 3 by 3, B also will be 3 by 3 matrix. If you multiply these two matrices first, then you take a determinant, it will be equal with, you take determinant of this matrix separately, then you multiply it. Then class, we go to the determinant of 2 by 2 matrix. This one you already learned before this. If you have here A, which is equal to the element of A, B, C, and D, then the determinant of this A matrix, which is denoted by determinant of A or this notation, will be equal with AD minus BC. The element of A times D minus the elements of B times C. Let's go to this example 1. We have now 2 by 2 matrix, which is here we have A, B, and C matrices. The question asks us to find its determinant. So we do first for example 1A. In this case, to compute the determinant of A matrix, it is equal to, we know that the theorem says it is AD minus BC. So now our A is 4, D is 1 for A matrix. So we have here 4 times 1 minus B is 3 and C is 7. So 3 times 7. So we have 4 minus 21, which is here the answer is negative 17. And then we compute here determinant of B, which is for this one, 1 times 3 AD minus 2 times 5, which is here 2 is B and 5 is C. So now we get the answer for this one, 3 minus 10, which is equal to negative 7. And then for determinant of C matrix, it is equal to 2 times 4 minus negative 1 times negative 2. In this case, it is A minus 2, which is equal to 6. So now we've got determinant for A, B, and C matrix. Then for B, show that number 1, determinant of A will be equal to the transpose of the A, and we take determinant. And number 2, if you multiply this matrix A and B, you take determinant. The question asks you to show that this one is equal to determinant of A times determinant of B. Means that in this case, we want to show the properties is correct. Okay. For this one, we need to take here first a transpose of matrix A. So in this case, we know that our A matrix is given by 4, 3, 7, 1. So here the A transpose here equal to 4, 7, 3, 1. And when we take here determinant of this matrix, it is equal to 4 times 1 minus 7 times 3, which is, when we solve, which is 4 minus 21, it is equal to negative 17. And then for number 2 here, for this case, we need to multiply first A and B. Our A multiply with B is given by 4, 3, 7, 1 times 1, 2, 5, 3. When we multiply these two matrices, we have here 4 times 1 plus 5 times 3. And then for the next element, 4 times 2 plus 3 times 3. And then the next element is 7 times 1. And then plus 1 times 5. The next element is 7 times 2 plus 1 times 3. When we solve this one, we will have here the answer positive 19, 17, 12, 17. Then we need to take the determinant of this multiplication of two matrices. It is 19 times 17 minus 12 times 17. When we solve this one, we got the answer 119. And then we need to show it is equal to determinant of A times determinant of B. Determinant of A is given by negative 17 and determinant of B is given by negative 7. When these two determinant is multiplied, which is here A determinant times B determinant, we got here negative 17 times negative 7. The answer is 119. So we can see here we have the same answer, means that determinant of AB equal to determinant of A times determinant of B. Next, we go to the determinant of matrices for 3 by 3. We can compute here determinant of matrix 3 by 3 via two approaches. Here we have method number 1 is by using diagonal expansion method, and method number 2 you can use minor and cofactor. We can go one by one in the next slide. So first we go here to the diagonal expansion method. If you have here matrix A, which is 3 times 3 matrix with these elements, so we can compute the determinant of this matrix by using adding 2 more columns on the right with its first 2 columns. Means that here you can see when we want to compute determinant of this A, originally we have only this part, but by using diagonal expansion, you can add another column outside of this matrix, but with which column to be added here? It is the first and the second column. So here I have elements A11, A21, A31 because this one comes from the first column and this one comes from the second column. Therefore, here we will have matrix 3 times 5. Then the determinant of this A can be computed by first this diagonal is multiplied, all elements at diagonal is multiplied. So we have A11 times A22 times A33. So we have here the first term. And then you add with the second diagonal here, A12 plus A23 plus A31. And then we add here with the third diagonal. So we have A13 times A21 times A32. And then the next one, we use here this side. Okay, when you use this side, you will got here negative answer. So here, for this side, you have this diagonal, and then this one, and also this one. Means that here, when we start from this diagonal, we have A12 times A21 times A33, but should be in negative form because it is opposite direction. And then minus A11, A23, A32 minus the last diagonal is A13, A22 and A31. This one is the formula to compute determinant of 3 by 3 matrix by using diagonal expansion. Now we want to solve this example 2. Given the following matrices, the question asks us to find determinant of the matrices. For this example, I will show you only for A, and then you can do as exercises for B and C. In this case, the determinant of the A can be computed using, we have here your matrix A, negative 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we can add another two columns outside of this matrix, which is a column number 1 and column number 2. In this case, we will have here additional column, negative 1, 4, 7, 2, 5, 8. And then we can compute here by using this diagonal element, and also this one, we'll got here negative 1 times 5 times 9 plus 2 times 6 times 7, and then plus 3 times 4 times 8. And then for minus part, actually it is on opposite direction, which is this main diagonal, this diagonal, and the elements at this diagonal. So we start from here, which is 2 times 4 times 9, and then again minus negative 1 times 6 times 8, minus for the last main diagonal 3, 5, 7. In this case, when we solve this one, we'll got the answer equal to 6. And then you can do the same way for B and C. For B, determinant, when you do this way, you will got the answer is negative 18. And for C, the answer is 42. So class, this is the way on how we can compute determinant using diagonal expansion. Then for the next video, I will show you how to compute determinant using minor and cofactor. Thank you class. See you in the next video.